Hi, this is Arcot Prakash presenting Redshift, an Amazon data warehouse solution for cloud computing at Harvard University Extension School. What is Redshift? It is a cloud-based data warehouse hosted entirely by Amazon Cloud Services. It is a columnar storage of data. Instead of the traditional row mechanism used for storing data in a database, Redshift uses a columnar storage where data is stored in columns right next to each other. This allows for AWS Redshift database engine to retrieve and write the data rather fast. The environment is fully managed by AWS, including the OS and all the way to the data warehouse. What does it provide? It provides incredibly massive parallel computing capabilities from a single node to multi-node that can have dozens of processors and gigabytes of memory to support the large data warehouse needs for, say, an organization such as biocomputing. Each database runs on its own node, making it highly scalable across nodes. What are some of the pros of the Redshift database? As I mentioned before, it is massively scalable because of its ability to distribute data across multiple nodes, and each node can be a small node with minimum amount of computing resources to ton of computing resources, fast performance. The queries are parallelized, hence resulting in fast response back from the nodes and query completion. AWS guarantees 99 plus percent of uptime on Redshift. It is fairly easy to set up and run. In a traditional data warehouse environment, it takes weeks and months to get the infrastructure up, the licenses up, to bring a data warehouse with the capabilities that AWS Redshift provides. I was able to bring up the AWS Redshift environment within hours. AWS manages the platform from soup to nuts. This feature allows your team to focus on architecting the data warehouse and the solution itself rather than focusing on the infrastructure, which, when outsourced to AWS, our focus shifts to solutions management within any organization. It allows you to plug your BI tools and get going with creating reports, spreadsheets, etc. It is incredibly cheap as well. It costs 1/5 to 1/10 of the traditional data warehouse solution. What are some of the cons? The compute node and the storage nodes are tied together, so it results in wasted CPUs when it is not used. Loading also petabytes of data into the warehouse can be pretty expensive. There are solutions to work around it, including sending data bricks to AWS, and additional solutions are on the way. But overall, AWS Redshift is an incredibly good solution for an inexpensive solution for in the marketplace. What is the architecture? The client architecture is such that you can connect your SQL clients using either JDBC or ODBC. The data warehouse architecture is such that there's a leader node that receives the connections from the various clients and client applications and distributes that work across nodes. Depending on whether you chose one node or multiple nodes, the leader node becomes aware of how many nodes are in the data warehouse cluster, and it distributes the work across those clusters rather evenly. And each compute node is put together by slices of additional small computing units, hence really providing the capability to scale the data warehouse tremendously. The architecture includes client applications like we discussed, such as SQL Workbench and other clients, the connections such as JDBC and ODBC. The cluster itself And a part of the cluster is the leader node, which receives the work, such as a query request, and distributes that query request to the different compute nodes, which breaks the work down further into the node slices. AWS internal network, of course, becomes part of the architecture as well, and the Redshift database itself is another part of the entire architecture. Each node has its own database as well. There are 4 management services together that make up the Redshift data warehouse. The first is the cluster management. The second is the cluster access and security. The third component is the monitoring of the clusters. And the fourth component is the database. I'm going to go into the details of each of these a little bit further. The cluster management. In the cluster management, you're basically creating and managing the cluster. You're deciding upfront whether you want a single node or multi-node. You can, of course, change how many nodes you have in your cluster further down the road as your needs change. So if you need to scale up, you can add multiple nodes. But if you need to also scale down your data warehouse, you can decrease the number of nodes in your cluster. In the interest of saving cost, AWS provides the option to reserve clusters. For longer use, you can take advantage of 1-year and 3-year reserve clusters. It substantially reduces your cost of renting these environments over 1 and 3-year periods. The cluster management also provides snapshots. So you can have automated snapshots, so every day, every 7 days, whatever the interval you choose, or you can manually create a snapshot if you had some large updates to either the code or the data itself and you want a snapshot of it. The cluster access and security. AWS accounts and IAM credentials are typically used to connect to the cluster. And the security groups that we can use for managing the clusters are either the traditional classic platform that you can use to connect to the cluster, or the VPC platform to manage the cluster security, such as which ports are open and what traffic can flow through those ports. AWS also provides encryption services. They have their own AWS key management service, but you can also incorporate hardware security module. And finally, to secure the data, you can use SSL connections if you so desire. Monitoring of the clusters. There are 3 components to monitoring a cluster or clusters. One is the database audit logging. The activities against the database or databases in the cluster can be monitored using the Redshift database audit logging. It provides query times, who accessed it, when the connection happened and when the disconnect happened, and also when the authentication request came in. It can be stored in S3 buckets for future queries as well. Events and notifications. You can set up simple notification services in AWS to notify you of key events that takes place in the Redshift environment. And when that event happened, a description of the event can be texted to you or emailed to you. Performance. The AWS Redshift cluster also has the ability to monitor its own performance, including the physical aspects of the cluster, such as CPU utilization, latency, and throughput. And the results are stored in CloudWatch if you so desire. Database is the final component of the Redshift engine is the database itself. The database is actually very similar to a PostgreSQL database. Client apps can query against this database using tools such as SQL Workbench, HeidiSQL, and other tools. Each database is provisioned per cluster. Additional databases can be added if your needs increase or change along the way. There are master users against the database, but it is recommended you create additional users with less privilege to be able to access the database to perform, say, basic functions like read against the Redshift database. The installation steps. The key installation steps are highlighted here below. You have to have the AWS credentials, which you can get for free. You can also actually get the AWS Redshift free trial for 750 hours, which is what I did for this project. You need a SQL client such as SQL Workbench to be able to query against the database, and Amazon provides the JDBC drivers as well as the ODBC drivers against it. You need to launch the Redshift cluster and finally provide access to the cluster, and from the SQL client you can connect to the cluster using the JDBC clients and load the sample database and query against the Redshift data warehouse. Here's what the installation steps would look like on the AWS environment. Once you enter the basic credentials and the type of cluster you want to create and proceed, you should have a healthy cluster created in fairly short order. In this screen, we are giving a basic description of how to connect to the Redshift cluster. This is a SQL Workbench connection profile that highlights what driver we're using. In this case, we're using a Redshift JDBC driver, and the URL points to the actual sample cluster that I created. And of course, you need to enter your master user or whatever the username that you created and the password against that account. To query the Redshift database, I'm going to quickly jump onto SQL Workbench to show how we can query the database. I've created 3 separate queries here. The first one, I'm going to go ahead and run it. It basically retrieves the sales figures for a region, and this sample query runs against the Redshift sample cluster that I created. Here's a second query. And the third query that compares quarter 1 sales data against quarter 2 and quarter 3 data set. Now I'm going to quickly jump onto the AWS console itself to show you the Redshift cluster. Here's the cluster that I had created for this project, and here's the sample cluster. I'm going to walk through the cluster details just a little bit. The cluster name, such as sample cluster, and the cluster type. Did I use a single node or a multiple node? In my case, I used a single node. And the type of node itself, the node ranges from a fairly small node to a very, very, very large node. And the cluster properties includes other details such as port. This is the port through which you can connect from your client machines. So that is important to make sure that the port that you set up here is available for connection from your client instances. And when you need to create the JDBC connection, you need the JDBC URL, and you can retrieve that from here. If you're using an ODBC tool set, you can use the ODBC URL from here. To monitor the status of the Redshift cluster, Amazon provides several tools, including the events log, and this logs all the major events that takes place against this cluster. As you can see, there are no major alarms at this point, but you could configure the alarms to send you CloudWatch alarms. Performance. Since this is a sample database, not much querying has been done against it, so you can see the performance is rather steady across the last few days. And finally, the queries tab. This lists all the queries that has been against this Redshift cluster, and you can narrow the query results down if you so further desire. I'm going to quickly jump onto reserved nodes. As you can see, I didn't use any reserved nodes, but if you had purchased reserved nodes, either 1 year or a 3-year package, you would see your reserved nodes and the status of those nodes as well. I wanted to finally give credit to AWS for all the materials that was provided to create this demo.